Welcome to section 8.6. We're going to look at solving nonlinear systems by substitution, elimination, and graphing. So that means we'll probably still see a line now and then, but it's going to be matched up with parabolas and circles and ellipse, maybe a hyperbola, maybe some exponential graphs, some log graphs. Who knows? The gamut's wide open. All right. What you should always remember is to graph and check your answers because extraneous solutions may occur. This is when you can do a conversion rule with your logs and your exponentials, or you square both sides and you somehow turn a false statement into a true statement. So we need to graph and check your answers. So let's solve the following system of equations. We have 3x minus y equals negative 2. That's a line. 2x squared minus y equals 0. That's a parabola. So thinking about, okay, there's a parabola, a line going through it, at most two possible intersections. All right, so what I'm going to do is, because I got a minus y in each equation, I'm going to do this by the elimination method. Take that first equation, multiply it by -1 to make that y a positive y. So I can add it to the second equation and cancel them out. So the 2x squared minus the 3x are not like terms, so they stay together. The y's cancel, and 0 plus 2 is 2. This is quadratic, and so now we're going to set this equal to 0. Well, we need to factor that. So since both the first leading term starts with a 2 and the constant is a -2, you know that the signs of your binomials have to be 1 plus, 1 minus. And to get to a -3 in the middle, the two 2's have to be multiplied to be a 4. There are other factors of 1 multiplied to get a 1. We subtract them, and we get a -3. All right, so that means the 4 has, or what, the 2 has to be negative as a constant. So 2x plus 1, x minus 2. So again, two factors of 2 are 2 and 1. So 2 with 1x, 1 in front of the other x. Factors of 2 are 1 and 2, but because we had to get to a 4 minus a 1, the 2's have to be multiplied, then the 1 has to be multiplied. -4x plus 1x minus 3x. Set those equal to 0, solving for x. That's going to give me x equals -1/2 and x equals 2. So I'm going to take those two answers, do some back substitution. I'm going to use the linear line, and you could use either one. So starting with this one, we'll put -1/2 in for x, which gives me 3 times -1/2 is -3/2. Solving for y, so I'm just going to add the y over to the right. That makes it positive. Add the 2 over to the -3/2. Well, 2 would be the same as 4 over 2. So 4 over 2 minus 3 over 2 is 1/2. And that gives me the ordered pair -1/2, +1/2. That's one intersection. We'll do the same thing with x equals 2. Substitute that in x. 3 times 2 is 6. Again, add the y over to the right, makes it positive. Add the 2 to the left, makes it a +8. There's my other intersection point. So how do we graph without having equations that are functions? All right, this is a line. Solve it for y. Add over the y, add over the 2, 3x plus 2. Parabola, well, that's a function. We can graph that. Add over the y, y equals 2x squared. When we get to those conic sections like circles or parabolas opening left and right, okay, those are going to be non-functions, and we'll show you the trick on how to graph those. So I'm going to go to a Zoom 6 window. There's my graph. I'm going to hit second, trace, number 5 for the intersection. I'm going to hit enter on y1, enter on y2, but move your cursor closer to the intersection to the left, and then hit enter, and that verifies the -1/2 and the 1/2. Second trace again, number 5, enter on y1, enter on y2, but now move that cursor closer to this intersection, and there's our 2/8, justifying that answer. All right, looking at our next example, well, here we got a circle, x squared plus y squared equals r squared. Ooh, that's an ugly radius of a square root of 13. X squared minus y is equal to 7. This is a parabola. So, whoops, going the wrong way here, mouse. So again, I see x squareds are the same. So I'm going to eliminate that. I'm going to multiply this equation by a negative 1. I don't want to make my y squared negative. So that's going to give me x squared plus y squared equals 13. Now with a negative x squared plus y equals negative 7 below it, add these together, cancel, y squared plus y equals 13 minus 7, 6. That's quadratic. We got to set it equal to 0. Factor it. 2 factors of 6, that subtract to be 1. 3 and 2 make the 2 negative and the 3 positive. Solve them for y. Y equals negative 3, y equals 2. And now we're going to back substitute those in. So I would probably pick the parabola, because that way I don't have to square the negative 3 or the 2. So let's see. We'll plug in negative 3 in for y, so that's going to be x squared minus a negative 3, which is a plus 3. Subtract the 3 to the 7, which is 4. Take the square root of 4, which is 2, but it's going to be a positive or negative 2. So this one y coordinate is going to create 2 x coordinates to correspond to it, which means that's 2 points right there. We'll do the same thing with y equals 2. X squared minus 2 equals 7. Add over the 2 to the 7 makes it a 9. Take the square root of 9 makes it a 3, but it's positive or negative. That 2 generates 2 possible points for intersections. So I have 4 intersections. I'm going to graph them and verify them. To do that, I would here graph or enter this one into y1 first. Add over the y, subtract over the 7, graph the parabola first if it's opening up or down. This is more difficult because this is not a function. Remember, y to an even power is not a function. You can solve it for y, subtract over the x squared, and take the square root of both sides, but you have to have a positive or negative, just like we did with the 2 and the 3 over here. So y2 is going to be my positive square root of 13 minus x squared. Now for y3, you could put negative square root of 13 minus x squared, but again, I'm efficient. I'm just going to put negative, then go alpha trace, number 2, and I want all the y2s, and I'm just going to make them negative. So I graph this. Here's my Zoom 6 window. My circle looks more like an ellipse, and yes, they do touch. It's just that the pixels can't get to the x-axis because they're not small enough. But if you wanted to clean this up, there's another zoom choice, Zoom 5, which squares your window. So you can see how my ellipse turned more into a circle. Does make the parabola a little skinnier. But the reason why this is in Zoom 6 looking like an ellipse is because your distance from 0 to 1 on the x-axis is wider than from 0 to 1 on the y-axis. All right, so looking at this window, let's go find the 4 intersections. And it looks like it's going to verify our 4 points. So again, second trace intersection. Enter on y1. Move your cursor to on the red curve, closer to the intersection on the left. Hit enter and enter on the guess, and you get negative 3, 2. Justifies this answer. Find over here on the right, come back here. Second trace, intersection number 5. First curve, enter for y1. Second curve, move your cursor over to here, enter on guess, you get 3, 2. That verifies this answer. For the bottom, now that black part of the curve, that's y3. So second trace intersection, enter on y1, but now you got to hit the down arrow to get to y3. Move your cursor to the left side, hit enter. There's negative 2, negative 3. And then we'll find this intersection over here. First curve y1, again, down arrow again, move your cursor over, hit enter, enter. There's my 2, -3. So that's how you enter equations that are not functions. All right, next system. Holy moly, x times y equals 4. Okay, this will have to be substitution. We don't have an xy term down here. So what I'm going to do is I'm going to solve that equation for y. I just divide over the x. So now we're going to take 4 over x and substitute it in for y. We're going to square the top and square the bottom. 16 over x squared. Well, we really can't solve for x if x is in the denominator, so what I opted to do to get rid of the denominator is to multiply x squared to all the terms. So 2x squared times x squared is 2x to the 4th. 16 over x squared times an x squared, they cancel, leaves me plus 16. Equals 18 times x squared, 18x squared. Set it equal to 0. Subtract over the 18x squared. Everything's in descending order as I write it, and I notice all my coefficients are multiples of 2, so I'm going to divide it by 2, which leaves me x to the 4th minus 9x squared plus 8x equals 0. Because one power is double that of another power, this is quadratic in nature. You can factor this. Two numbers that multiply to be 8 and add up to 9, 8 and 1. They're both minus signs. So you just use x squared, that's the middle term, x squared, to lead off each binomial. Set those equal to 0. X squared minus 8 equals 0. X equals 8. Square root both sides. You get a positive or negative 2 radical 2. 8 breaks down to 4 times 2. The square root of 4 is 2 on the outside. The 2 left over on the inside. X squared minus 1 equals 0. Add over the 1. Square root of both sides. Plus or minus 1. Or positive negative 1. Bring back your y equals 4 over x. This is going to get a little messy with this one. So substituting in just the positive 2 square root of 2 in the denominator of 4. This is the x coordinate that goes with it. All right, so I'm going to rationalize this the y coordinate by multiplying the square root of 2 top and bottom. So square root of 2 times the square root of 2 is the square root of 4, which is 2, times the 2 on the outside makes us a 4. Oh, look, the 4's cancel, leaves me the square root of 2. So my first point is 2 square root of 2, comma 2. Now, the negative 2 square root of 2 goes in for the x, makes this negative, this negative. Well, that's just going to simplify to the same as if they're both positive. So I just took the negative and put it on my x and my y, and there's my 2 intersection points. Do the same thing with 1. You'll have 4 over 1, 4 over negative 1. So we have 1 comma 4. Then when x is negative 1, we get a negative 4. There's my 4 intersection points. Again, if you were to graph this, this is what we're going to have to type in for the first equation. And then you're going to solve this for y, subtract over the 2x squared to the 18, take the square root of both sides just like we did with the circle, 1 positive, 1 negative. The nice thing about using the negative y, you can just go, negative y2 for y3 is all you have to do is change y2, and you don't have to make any changes to the y sub 3 equation. All right. Solving, ooh, holy cow. Wait, whoa. Log base x, okay, hold it, time out. We have restrictions here. On your base, we cannot have any negative bases. So the base had to be greater than 0, and let's see, and it couldn't be a 1. All right, that's your base restriction on logs and exponentials. And for my y here, Since it's on the inside of the log, it has to be positive. So y's have to be greater than 0. All right? We can't even have a 0 in there. We wanted a positive. So if I get any answers that violate these restrictions, that would hence be an extraneous solution, and we throw it out. So to solve this, holy cow, we're going to have to convert these to exponentials. So this would be base x to the power of 3 equal to 2y. And our second one would be base x to the power of 2 equal to 4y. Excuse me. So we'll solve this by substitution. Pick either equation, doesn't matter, solve it for y. I divided the 2 over, so x cubed over 2 is equal to y. I'm then going to substitute it into this y. 4 times x cubed over 2, well, 2 goes into 4 twice, so x squared equals 2x cubed. Set it equal to 0, subtract over the x squared. Always keep the x with the biggest power positive. Factor out an x squared. X squared times the binomial 2x minus 1. Solve for x. X squared equals 0 means x equals 0. 2x minus 1 equals 0 means x, add over the 1, divide by 2. There's my 2 and, wait a minute. X has to be greater than 0. We can't be equal to 0. We just violated our restriction, throw that out. So take x equals 1/2. Let's go solve for y. We'll plug it into this equation right here. So x cubed over 2. All right, so I don't like putting a fraction in the numerator of a fraction. So division of 2 is the same as saying 1/2 times x cubed. Can we agree with that right there? Good, thank you. Substitute in the 1/2 for x. Okay, we cubed that. 1 cubed is 1, 2 cubed is 8. 1/2 times 1/8, 1/16. That's my y value. When x is 1/2, there's my intersection. So that's the examples you'll see for non-linear systems.